teddy bears, all the things.
That was Superman.
Okay.
Wonder Woman, man. She
Yeah.
took with the show.
All right.
She was in this.
Polar. I
Special
say
thanks, Mr. T.
polar. Roger, in the world of calculus BC, what does that mean to you? And are we filming now?
Yeah.
Good. Polar, what's the thing? What's the thing you need to know in the world of polar?
Photographs.
Polar graphs, polar curve, what does it even mean? Like if I say polar coordinate system,
We're going to be measuring in R and theta.
we're going to be measuring using r and theta, right? And the analogy that I wanted you guys to keep in mind is who lives in the polar world?
Superman.
Superman lives in the polar world because in the polar world, Superman says, oh, I'm over here. He doesn't call it the origin, he calls it the pole, right? It's the point, whatever. And so he says, I want to get to this point. He says, what's the radius? What's the angle? And he just says, boom, there I am. This is how Superman lives. Superman is in charge of the polar world.
Hey.
The other option, Nathan?
Rectangle?
You've got the rectangular world. In the rectangular world, this is the world you guys have lived in, oh, forever. And you know that this is called your origin. Great. And we're always going to think about Batman driving along on the streets of, wow, apparently that's a crooked road in Gotham City there. Okay, there's X, there's Y at right angles. I'm describing the same point in space, but I'm using the rectangular coordinate system here. I'm using the polar coordinate system over here. Here's my friend Batman. Great. I need transformation equations. I need them to be able to speak to one another.
So polar, and the first one's R equals the square root of x squared plus y.
Okay, if you're going from polar over to rectangular, so if you know the radius and the angle, Roger, I heard you say, what are we gonna do?
R equals the square root.
But the problem is you're going from polar where you know the r and the theta, and what I want is the x and the y
okay,
coordinates.
x equals R times cosine.
Okay, so the x coordinate is r times cosine theta. Roger, you're frozen for just a little bit. If x is equal to r cosine theta, y is going to be equal to r sine theta. Brian, you are now frozen as well. Okay, you know r and theta. You get over to rectangular by x equals r cosine theta, y equals r sine theta. AP Physics folks, you guys are doing this all the time, right?
We are?
They've seen it.
Projectile
You've
motion.
seen it. I mean, all the time.
Projectile
All the time. Right, with projectiles, when you want to look at the horizontal and the vertical component of a vector, this is what you would do. Rectangular to polar.
Wait, hold up. What about theta?
What about theta?
Don't I have to measure theta as well?
No, this is going from polar to rectangular.
Right.
Yeah, my
As the
bad.
next
From polar to rectangular, those are the
Sorry.
transformation equations. I want to go the other way. If you know x and y and you want to get the r and the theta.
So theta equals arctangent of x, y minus x, y divided by
Theta
x.
is equal to arctan of y divided by x, and that's always true.
X greater than 0.
Right. This is how things work if you're in quadrants 1 or 4. If I'm over in these two quadrants, that's going to be the transformation equation for the angle. The issue is that the tangent has its principal domain from negative pi over 2 to pi over 2. It never gives you answers over here. Okay, so you're frozen now. How do I get the ratings?
What was the other equation for theta?
We're going to get that. So in this case, if you're in quadrants 1 or 4, theta is arctan y over x, where x greater than 0. How do you get the radius?
They're in R.
Square root of
That's an arc.
square root
Uh-huh.
X squared plus y squared.
R is equal to the square root of x squared plus y squared. I have no idea why you didn't know that was an R. That's clearly an R. Okay. So quadrants 1 and 4, theta equals arctan y over x. Now the question is, what happens if you're going to be over here? How do you get there?
You add a pi.
It's really just by adding pi. Okay. So theta is going to be arctan y over x plus pi if x is less than 0 and r is still square root of x squared plus y squared. Now, we talked about this yesterday. In the world of polar, there's no restriction on r. R could be a negative number. It's okay. It would just mean you have your angle, and if r is negative, rather than going in the forward direction, you move in the opposite direction. Okay? With the angle, you don't have to think from the 0 go around. You could go 0, go in the clockwise direction and use the negatives. You could do something crazy. You could say, oh, let me go around to 2 pi, and then a little bit more. And the visual I wanted you to think about yesterday was like, it's like Superman saying, I'm here at the pole, I want to go over there to that point, and what Superman does is, I want to go to that point. Yeah, let me go to that point. Oh, don't do that. Right, he wouldn't, that's not what you would normally do. You could do that if you struck by red kryptonite or something, but all the friends are okay? All right, here's what I want to do. Roger, you okay? Looks scary.
Yeah, you're right.
He misses Victoria.
All right, I want you guys to show me what you can do with examples 1, 2, 3, and 4. The goal here is for you to take what you know about graphing on your calculator
Just give
in
us
Polar and make me some pretty graphs.
You got the
You're
zero.
ugly. We're all ugly.
What? Pretty graph, take a test.
You know you're right. It's
Okay.
And Roger, do you mind driving the calculator?
Of course I do.
Yeah, he can
No,
drive
I-
a calculator. Of course, I would look into it. Even Mr. T has one. He doesn't even have a license.
What?
What? I got the little thing.
What thing?
Look. Like, it's so small. Mr. D,
Uh-huh.
for the first one, is it supposed to be that small?
Hold on a second.
I don't like zoom in so it looks like a
Yeah,
heart.
but is it supposed to be that small?
That's what I got.
Yeah, it's okay.
Oh.
Yeah. The nice thing is your calculator has mostly the same features in polar and parametric mode as it does in rectangular mode. You can zoom in, you can do all the things.
Yeah, that's one.
It looks like 2 leaves.
And that should work. Let's see what happens. What's going on?
I don't know. That's perfect.
That's plugged in. That's plugged in there.
Mr. T's self-tellers.
Uh-huh.
Okay, give me a preparation.
You wanna borrow mine?
No, it's okay.
No, it has to do with the cable.
I'm getting all off.
Hey,
It's like a bow.
I can't.
It looks like a rose. Lily pads.
Yeah,
These are leaves from the lily pads.
but
This one?
I think it was supposed to be this small. It looks like there's a one right there.
I mean, mine's just zoomed in.
Okay, not really sure what's
So
going
the
on
scale
there,
isn't.
but not gonna be the end of the world. Roger, why don't you come on back and join us? For whatever reason, the projector thing's not working.
Check where he checked.
Yeah, don't worry about it, Jeff.
You
You just broke it.
Yeah, you probably broke it. Too much cow.
Really check where he broke it. You just admit.
Roger, one. So, my D did it.
If you're interested in some of this stuff. Yeah, we've seen number 1 before.
The oval.
Wasn't it open?
It is.
It's an oval.
It is?
Yeah. Press A. Dude, This is
Mmm,
from
I thought that's what
0.
you did. Brian, what did you do for number 2?
that's from 0 all the way to 5.
Like a circle.
Look at the boundaries. That does not look like that. That's
I made mine zoomed in.
Sure.
What did you do for number 2?
for number 2. Oh,
And what'd you do for
that's
number 2?
theta.
Okay, just keep going, we'll talk. We'll talk in a minute.
It's theta, it's not R.
So I was
What about it? Is mine wrong?
Is your theta equals pi over 4.
Your theta equals pi over 4.
Now your r.
I still have not seen the right answer for number 2. 1, 3, and 4 are looking good. Your calculator is doing a great job on 1, 3, and 4. Brian, what's the epiphany that you just had?
It says theta equals pi over 4.
Theta equals pi over 4, and if you try graphing theta equals pi over 4 on the calculator, guess what?
It's nothing.
You can't do this. It doesn't mean there's no graph, it just means you can't use your calculator. Now, the big mistake that I saw most of you guys is you had something that looks like that,
That was me.
right? Nathan, what happened? Folks that are coming up with that in their calculator, what do you think they're doing?
I think they did with R. They think it's R.
Right, instead of theta, what they're doing is they're graphing r equals pi over 4. Check it. If I said r equals pi over 4, that's going to give you the graph of a circle, right?
Oval.
Circle.
It's an oval.
No, it looks like an oval when you zoom in.
It is because of your window. If you hit window,
Yeah, it looks like an oval.
okay, listen,
This is
window, zoom,
I never
square.
Square.
Zoom square. If you, and this is what I wanted to show you on the computer, but for whatever reason it's not working.
Square.
If you graph any of these, if you hit menu,
Let's make it look like a square.
window,
Oh.
To square the
zoom
grid.
square, right? It probably isn't even something you know exists
Oh.
on the calculator because you have to scroll down. Select zoom square. Especially in the world of polar, circles need to look like circles. It's not an oval, it's a circle.
Could it be possible to have an oval?
What?
Could it be possible to have an
It is absolutely possible to be an oval. It is not possible for r equals pi over 4 to be an oval. It has to be a circle. Why a circle?
Because they're all the same length.
Same radius.
So when I say r equals pi over 4, it means the radius has to be the same. The radius is constant. And what about the angle?
It's like,
Doesn't matter the angle.
Right, the angle's not a part of this. The radius is a part of this. So with that, have a quick conversation with somebody near you. What are you going to do with theta equals pi over 4? Don't tell me to tell your neighbor.
Then you just gotta go.
The radius doesn't really matter. The angle's already set, so it
Just goes off.
goes up on that angle.
If theta is equal to pi over 4, what you're telling me is the angle is the same all the time. The angle is always pi over 4.
Wait, is it only on the positive side? Or is it always? It's only positive 1 or always positive?
Eva, do you know what R is?
No.
They would, oh, you know, so theta is. What is a constant theta?
Okay. So if the angle is only ever equal to pi over 4, what's the radius?
Doesn't matter.
The radius has nothing to do with this problem whatsoever. The angle is pi over 4. Brian, can you give me an example of a point in polar where the angle is pi over 4?
I'll give you any radius.
Any point at all.
Pi over 4.
One more time.
20 pi.
20 pi over 4. Okay. So I'm going to set an angle of pi over 4, and then that says, oh, go out 20 spaces. Here's the point, 20 comma pi over 4. Nathan, can you give me another point?
1, pi over 4.
Thank you for being kinder to me. I'm going to set the same angle, and I'm going to go forward 1 space. Chepe, can you give me another point?
20,000.
20,000. Thank you. All the way over there. I think I'm going to write on the ceiling. Okay. Darn, if only Anthony was here and Victoria was here. Is everybody okay that that's what the graph would look like?
Yeah.
Nobody wants to argue this point with me?
Wait, so wouldn't
Nobody wants to argue the point with me?
why would
wouldn't it also go in classroom 3?
How can I possibly go in quadrant number 3?
Still rotating.
Oh, because your radius is still going.
Yeah, oh yeah, the
Right.
radius.
The angle is pi over 4. What's the radius?
Doesn't matter.
Yeah, it doesn't matter.
It could be anything. It doesn't matter what the radius is. How am I going to get into quadrant number 3, Nathan? How are you going to get there? What would you do with the radius?
That's fine.
Like a negative.
What?
Right, so you could say, oh, I know, this is the point, you know, let's see, if I'm Nathan, you're gonna say like negative a billion, right, or whatever, comma, pi over 4. The key though is your angle over here is pi over 4. Your angle is pi over 4, but now you're going backwards. What you're gonna get is you're gonna get a line passing through the origin or the pole. What's the slope? Slope is pi over 4. And I realize for the 7 of us all together, you guys are new to the world of polar. We have spent about 45 minutes in the world of polar. The slope,
Pi over 4.
pi over 4.
Forward.
4, 0.
What would it be?
Hopefully 0 doesn't make sense to anybody in the room or anybody ever watching this video, Roger, because what's the slope of that line?
1.
The slope of that line is going to be 1, not 0. Not 0, that would be a horizontal line. This is going to have a slope of 1 because if your angle here is 45 degrees, what this really is, it's the line y equals x. Okay, we are brand new to the world of polar. I understand. And I'm going to push you guys anyway. Right. Correct. If I change my angle, what I'm going to do is I'm going to change the steepness of the line. I'm changing the slope. Good question. Nathan, you're good? Mr. T, you're all right? All right. We are going to skip, for those of you following along in my lesson plan, we are going to skip this next part and go straight over to the world of polar. I think you guys are gonna love this. Oh my God, gonna love it. Gonna love it, exactly. And I always say it because it's always true, Roger. Always true.
We all fail.
No. In the world of polar, one of the things I'm very interested in us being able to do is talk about derivatives. Not only are we going to talk about derivatives in polar, yes, on Monday, for those of you that are going to be here on Monday, we're going to talk about integrals in polar form. We're going to look at how you would find the area of some of these things. Absolutely beautiful stuff, Roger. You're dropping the class? Okay, I understand. All right, so let's pick a point. Any point at all, it doesn't matter to me. Here is my point, but this point lives in the polar world. That point gets described as r comma theta. Okay? What I want to do is I want to talk about the slope of the tangent line. If I were to draw in my little tangent line, here's my tangent line. You guys have known forever and a day that the way we find the slope of a tangent line, tan, the way that we find slope of a tangent line in calculus class, it's not just y over x though, it's the change in y. It's the instantaneous change in y over the instantaneous change in x. Now here's the problem. In rectangular, this is easy, right? It's easy at this point for us. We have all these derivative rules. However, in the world of polar, it's hard to talk about how is y changing and how is x changing when there's not even a y and an x for us to be talking about, right? We have r and we have theta. What I want to do is have conversations about y and x. We okay? So here's how we're going to get there. Rather than saying find dy dx, we're going to find the derivative of y with respect to theta, and we're going to find the derivative of x with respect to theta. This ought to look familiar. This is exactly what we did in the world of parametric mode, right? In parametrics, if I said find the slope of the tangent line, you guys would all tell me slope of a tangent line in parametric mode. We've been there for 2.5
dy over
days.
dt.
It's dy over dt,
Over
dx over dt, because in parametric mode, y depends on t and x depends on t. Now, what's a little bit weird here is now I've got this weird mix, right? I want the derivative of y with respect to theta, but y is in rectangular, and theta is over in polar. How can I possibly talk about how y changes with respect to theta? I'm mixing my worlds here. Same thing over here. The key is to remember that x and y can be rewritten, right? X is really r times cosine of theta. Y is really r times sine of theta. So if I ask you to find dy d theta, I'm asking you to find the derivative of y with respect to theta. Well, the derivative of r sine theta. The derivative of r times sine theta with respect to theta is going to be a product rule. We're going to take the derivative of r. That's dr d theta. We're going to leave sine theta alone. Plus, now we're going to leave r alone, and we're going to take the derivative of sine theta, which is cosine theta. To find dx d theta, we're going to find the derivative of r sine theta with respect to theta. I'll give you guys a second to get caught up and find that derivative.
Wait, why is it r sine? Is it a cosine theta?
Why is it, thank you.
Victoria, catch mistakes.
Love it when you guys are absent, that way there we have like evidence. So to find dy d theta, we take the derivative of the y version using polar, so r sine theta. Do the same thing down here. If all goes well, we're going to have dr d theta cosine of theta plus r times derivative of cosine is really negative sine theta. And so if you guys don't mind, I'm going to write it as negative r sine theta. What I'm really after, though, is I want dy dx, because dy dx is the slope of tangent. To get dy dx, we're going to take this guy here, divided by this guy here. We've got dr d theta of sine theta plus r cosine theta. We've got dr d theta of cosine theta minus r sine theta. There it is, lo and behold, that's how we're going to find the slope of a tangent line in polar form.
Don't the dr and d thetas cancel out?
Good question.
No.
I want to hold that thought for everybody to get caught up.
Okay.
I know I just went super
I
fast here.
can't take it out of both of them.
I know I just went super fast. As super smart as all of you guys are, I hope you have lots of questions right now.
So when you find the tangent radius,
Right, you're going to find the derivative of the radius with respect to theta, and that's okay because the radius is a function of theta. All those problems you guys did before, it was like r equals sine of theta cosine squared theta. I'm going to find the derivative there. Great question. Your question was dr d thetas, can they cancel out?
Yeah, I saw it.
Okay, why can't they cancel out?
Because the r cosine doesn't have the dr theta, so they can't factor them out.
Right, the only way I could cancel dr d theta in the top and the bottom is if dr d theta was a factor of the numerator and dr d theta was a factor of the denominator. Absolutely true. Roger, what questions do you have for me? You okay? Cheppy, what questions do you have for me? Nathan?
I think I'm ready.
We're good? Okay, now, here's the thing. Some of this just has to get memorized. Some of this, if you understand it, you don't have to bother memorizing. Okay? Here are the things that I think really are important to memorize. You have to know the transformation equations x equals r cosine theta and y equals r sine theta. AP Physics folks, you have an advantage. You've done this more often than the non-AP Physics folks do.
You did.
No, we
Yeah,
don't.
we can thank Mr. T for that. All right.
Brushed it off.
Honestly, I would not bother. I truly do not have this memorized
Oh.
ever. If you came up to me 10 minutes after class was over and said, hey, Mr. DeRozier, what's the slope of the tangent line in polar form? I'd be like, hold on, wait a second. I don't have this on lockdown. And I don't need you to have it on lockdown.
Is that a calculator?
The part that you do have to have on lockdown is you need to remember that in polar, if I want to find the slope of the tangent line, this is the key over here, right? dy dx is really dy d theta over dx d theta. Whatever the x is, I can find its derivative using my basic derivative skills, and I can find this guy here as well. Questions on that?
If an R, because if we're just choosing one point, isn't that gonna make the right side of both equations 0?
If r is a point, yes, but we don't normally find a derivative at a point. You find a derivative of the function first, then evaluate. Okay, so I want to keep track of some things here. There are 4 different derivatives here. We've got dx d theta. Dx d theta, what are we measuring?
X.
We're measuring x. Be specific though. Dx d theta means what? It means the derivative, but in terms of what does it mean? What are
In
you
terms of
measuring?
x, in terms of your x position.
It tells me how the x is changing, right? So this is the measure of how the x changes. I'm going to put the horizontal position changes. How the horizontal position changes as the angle theta changes, right? That's what dx d theta is. How is x changing with respect to theta? That's one of the 4 derivatives. What other derivatives do we see here? There's 3 more.
dy over d.
dy d theta. Ryan, what is dy d theta going to tell you?
Y changes for the vertical position.
Right? How y changes, and really when you say y, we're talking about the vertical position changes as theta changes, okay? That's 2 of the derivatives that we've just talked about. What else?
dy over dx.
We've got dy over dx. What is that dy over dx there for?
The change of your y as your
Change of y and x.
Change in y over change in x. Really what this is this is really like the slope of your tangent line. Right, this is the thing that we've worked with forever, and we're just sort of bringing it forward into the world of polar. But dx d theta is measuring how the point moves left and right as the theta value changes. dy d theta, how does the point move vertically? If dy d theta is positive, direction of movement is? The dy d theta is positive.
I think your
As
y
theta gets bigger, where does y go?
up.
It's going to go up, the point's moving up. If dx d theta is negative, I'm going to the left. Okay, so we've got dx d theta, we get dy d theta, we get dy dx. What's left? There's one more. dr d theta.
Oh.
dr d theta. Chepe, what do you think about dr d theta here?
Yes.
So it's the length of the radius, right? So you're talking about how the radius is changing. Okay, so this is the measure of how the radius changes. How the radius changes as theta changes. So if I said dr d theta is positive, what would this mean? Tell somebody near you, dr d theta is positive. What would that tell you?
So your radius
So
will
radius
be
is like
positive.
So if dr d theta is positive, then as the angle increases, the radius increases. Right, so I'm increasing my angle and the radius increases. We're okay? Roger, you good with that? Now here's the thing, and I get this one wrong all the time, all the time. If the angle increases and the radius increases, then the point is moving away from the pole. True or false?
False.
If the angle increases and the radius is increasing, then I am moving away from the pole.
False.
False. Angle increases, radius increases, moving away from the pole. True.
False.
False. Unsure. Thank you for the honesty. Okay. Angle increases.
Yeah.
dr d theta is positive.
Yeah.
What does that mean about the radius? The radius is getting longer. So what happens to the point? The little point that we're looking at as it's moving, where does the point go? When you think about a point, and I realize we are on the struggle bus because we are so brand new to the world of polar.
Wait, you said that the radius is increasing and the theta is
I
increasing.
said dr d theta is positive.
Okay.
Angle increases, radius increases. Does that mean that the point is moving further away from the center?
False. How is it? I mean,
You're thinking false.
You said it goes like, you're saying that theta
You
is
think
going
it's
up and the radius is going up
true.
at the same time.
I think it's,
You gonna go with true?
I'll go.
Not true.
Not sure, thank you for the honesty.
Maybe false.
Could it be false?
I think it goes backwards.
But you said the radius is increasing.
Yes.
So that means it's getting further from the center.
Or you go
Okay.
toward, depending if you're starting on the third quadrant.
So the key
But that
is
makes it be decreasing and
is
then
R
change to a-
positive? And that's why I get this question wrong every single year. If R is already a positive number,
That's what I did before.
right? If R is positive, then you're moving away from the center, right? And as the angle increases, if this guy's positive, then what you're saying is the radius becomes more positive. You move further from the center. But what if your radius is negative? If your radius is negative, if it's saying point in the other direction, when the angle gets bigger, saying that dr d theta is positive means that the radius becomes less negative.
So isn't that just a case of not being provided enough information to know?
Correct.
So how can you answer the question from that? What answer choice would you choose?
And now we're in the legal department, sorry. So here's the thing. If the radius is positive and dr d theta is positive, conclusion is
Increasing.
the radius is increasing and the point is moving away from the pole, right? My angle increases and I'm moving away. But if the radius is negative, meaning I'm like pointing, I can't really do this well with my hand, I'm pointing here, and dr d theta is positive, what's happening is the radius becomes less negative as you're moving. Really tough, tricky stuff. And you guys are doing just fine. For like 75 minutes in the world of polar. Good. All right. So let's do it. If all goes well, we're going to get through one of these two problems, and that's okie dokie. All right. Take a minute, read this over, think about your strategy, be ready to talk in a minute.
a game plan.
I'm back to 7 now. I just have to decide if I trade it up or not.
Your replacements. Guinea pigs.
I just figured out what you meant by that.
All right, slope of the curve, r equals 3 sine 2 theta. If you had an exceptionally gifted calculus BC teacher, then they probably have a formula memorized. Sadly, you don't.
Do I have a formula?
There is a formula. We just went through and developed it, and you turned your page, and you've completely forgotten it.
Oh, that one.
Things that you need to remember.
X equals 1 times cos theta.
You need to know for sure that the way that I get x is that x is r cosine theta. Other things we need for sure
Y equals R.
is that y equals r sine theta. Chepe, you and your cheating paper are frozen now. X is r cosine theta. Y is r sine theta. Brian, what other things are really important for us here?
dy over dx equals
All right, dy over dx. The way that we find dy dx in polar world, where everything is dependent on the angle, is
dy over d beta divided by dx d beta.
right, dy d theta dx d theta. I think these are the mission critical things for you to just know and have locked down. That x equals r cosine theta, this is how I translate over to the rectangular world. Here's how I find the derivative in the polar world. Great. So now I need to get dy d theta. Well, let's get x. If x equals r cosine theta, well, what's r? R is 3 sine 2 theta. So my x value at any angle theta is 3 sine 2 theta times cosine theta. This is x. What I need dx d theta. What I hope is that once we get here, this part feels good. That this part feels pretty comfortable, right? So I'll give you a second. I'm going to work it out, but don't look up until you're ready.
No, Carl.
Now we take derivatives of both. Oh, I see what you're doing. I see what you're doing. Your friends over here, how does it? Yeah. This is definitely another part in the Calculus BC curriculum where it is important for me to stop and practice in the morning. It's not-
So everything that's BC, you have to stop and practice,
Because the last time I formally taught it was 3 years ago.
and that one's good.
Whereas like AB, all the things I could be half asleep at 5. BC, full brain, all the time. Okay.
What do we do?
Okay, how are we doing with just the derivative process? We're okay?
Yeah.
Really? Make sure you've got your transformation equations. Make sure you know how to find the derivative. And then really, once you've set it up, the fact that it's theta at this level with your smarticle particles, that cannot be the thing that we're worried about. But oh, how do I find the derivative of theta? Same way you would for x or t or any of the other things. Now the problem is, we're not done.
Plug it in.
Right, you actually have to go through and find slope of tangent line at pi over 3.
It's always
My
calculator
God.
active.
Yeah.
And it's calculator inactive.
What?
Why not? Okay, 3 cosine 2 theta times 2, that's really 6 cosine of 2 pi over 3. Nice, and then I'm going to multiply that with the cosine of pi over 3. And then I'm going to subtract 3 times the sine of 2 pi over 3 times the sine of pi over 3. Okay, cosine 2 pi over 3. You wish.
A half. That's negative a half.
You wish it
Square
was
root of
0.
Negative a half.
Square root of 3 over 2.
No.
There is no shame with drawing yourself a little unit circle. 2 pi over 3. Pi over 3 is 60. 2 pi over 3
Negative
is...
a half.
Right, 120 degrees. If that's 60, then this guy over here is square root of 3 over 2, and that guy over there is going to be negative a half. Okay. So cosine of 2 pi over 3, negative a half. Negative 3. Cosine of pi over 3,
A half.
that's a half. Minus 3 times, I need the sine of 2 pi over 3. Square root of 3 over 2 times sine of pi over 3. Square root of 3 over 2. Gotta clean it up a little bit. Negative 3 halves minus square root of 3 over 2 times square root of 3 over 2
3 over 4.
is square root of 9 over 4. That's really 3 over 4. So here's like minus 9 over 4, and if you clean that up a little bit, I think you get to negative 15 over 4. You're gonna go through and you're gonna do similar things over here. But neither of those are your slope. None of them are the slope.
Because we divide them by...
You then have to take the quotient. You have to say, what's dy d theta? What's dx d theta? You've got to divide them, and then that gives you the slope. We are going to spend, I'm so glad, I think Victoria and Anthony are back on Monday. We are going to spend Monday just in the world of derivatives with polar curves, because integration will blow your minds.
Do I have to find a second derivative or no?
Oh dear God, no.
No.
I do not like that much pain in my life. Homework this weekend.
That's nothing.
Homework this weekend has nothing to do with
This.
derivatives. What I want to give you guys this weekend, yeah, you can stop filming. This is